Okay, cool. So it's live.
Yeah.
Okay, great. That was so weird.
That was.
Oh well.
It was also weird because when you left, the meeting kept going.
Oh really?
Yeah.
I was like, how did I do that?
That's weird.
Anyway.
Okay. You guys ready?
Mm-hmm.
I am.
Great.
You want me to read 3?
Sure.
The symbol for the true population proportion is which of the following? P, N, or with the little, whatever that's called, P hat, or just P?
It's just P.
Yeah.
So for a confidence interval, it's with P hat, and with the hypothesis test, it's just P, I think. So it's true for both of them
Yeah.
Yeah.
because you get 10 and 90 for the first one, and then you get 25 and 75 for the second one.
Yep.
Oh, so conducting a hypothesis test, you use P hat.
What?
So for number 5, you use P hat.
For number 5, you just use P. For number 4, you use P hat.
Okay.
Also, guys, I tried the homework yesterday because I was feeling really good after our meeting, and I did really
Was it not good?
It was hard. I was like, okay, I don't know how to do that. So I waited to try my second attempt until I understood it better.
You mean
That's good.
lesson 16?
Yeah, for lesson 16. I did the homework right after our group meeting, and I was like,
Wait a
Never
second.
bad.
It's okay.
Okay, a study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Find P hat, the point estimate of the proportion of first-degree murder defendants who are found guilty in this state.
That 45 divided by 60?
Yeah, I'm pretty sure. So they said to round to 3, but if it's 0.75, is that fine?
I think so.
Yeah.
You can't really make that be 3. So. Whoa, it's got really bright in my room. Okay. Create a 95% confidence interval for the true portion of first-degree murder trials in this state. There, the verdict is guilty. Input your answers for the margin of error, lower bound and upper bound. Determine the margin of error for this 95% confidence interval.
Okay, so we do this through the Excel sheet, right? The new one.
I think so.
So what do you do for the type of test? Which one is it?
Well, for a confidence interval, it wouldn't matter.
Oh, it doesn't matter.
Not what the confidence interval. For the P-score and the test to statistic, it does.
Okay. lower bound would be 0.64 and the upper bound would be 0.86. Is that what you guys got?
I didn't finish.
Okay.
The lower bound and upper bound kind of confuse me sometimes, depending on what we're doing.
And it should be so easy, but it confuses me too.
Yeah, I was like, I should know this. And then I do it and it never turns out right.
And then the margin of error, you would subtract the difference and divide it by 2. Yeah, to get that.
Well, I was calculating them all by hand. I haven't really done it on the spreadsheet, except once. Okay. What was number 7?
Number 7? What
Yeah,
did you guys get the same thing for the lower and upper bound?
and 60.
Yes, I got 0.640 for lower bound and 860 for upper bound.
Oh, so you put the zeros at the end of that one?
Yeah.
So is the margin of error 0.11?
Yeah.
Did you do 110 or just 11?
I just put 1-1.
I'm so confused. I don't like that they say round to 3.
I don't know. I don't know if it really matters.
0.11. Oh, you don't have to have the 0.
Okay.
Yeah.
If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? It would
Increase.
If you increase the sample size, the confidence interval would decrease. Is that right? Is that what you said?
Yeah, that's
Yeah, I think so.
Oh wait, what did you put for the lower bound? Oh, I think I put these in the wrong place. I put the lower and upper bound in the wrong place. What was it? Wait, sorry. So was the upper 0.86? Or am I confused?
The lower is 0.640 and the upper is 0.860.
Or 0.4. Wait, I'm sorry. What did you say? The lower? Point
The lower is 0.640.
Okay, I'm caught up here. What?
Did you get the upper?
Yeah, 860. Okay. And this will. So if you increase, then it decreases the. So number 10 is decrease, right?
Mm-hmm.
All right, I'm here.
Okay.
To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1.5. What is the smallest and can be in both requirements still be met?
Suppose P is 0.5. Okay.
Do we know? Oh, okay. Then that formula. Oh, 10 divided
I think it's 20, right?
Yeah, I think so too.
Because it ends up being the same formula for both. Because you're multiplying 0.5. 1 minus P is 0.5. And the other one's already 0.5.
Yeah. 20.
Oh, so it's the same question for number 12, except for with different P.
I get 12.
I think it's 100.
Yeah, that's what I got too.
Because for the first one, 100 times 0.1 is greater than 10. And that's the smallest that it can be for that one.
Can you take 10 and divide it by P?
Yeah, that's what I'm doing. 10 divided by P, and then you get what you need.
And then 10 divided by 1 minus P.
Yeah, so I do 1 minus P first, and then I'll do 10 divided by whatever I get.
Isn't 1.9? Isn't
It's 0.9, yeah.
so 1 divided by 10 divided by 0.9 is 11.1111.
Yeah, but 11.1111 wouldn't satisfy the first one, and both of them have to be met. So the smallest number that first one can be is 100. So that means that that's the answer.
First one. So 10 divided by 0.1
is 100.
Oh yeah. Okay, definitely 100 is the answer.
Did you get that?
I get 10. First time.
Do you understand how to do that, Diana?
Yeah. Yep. Okay.
Okay, for the water quality study in the reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using the significance level 0.05 with the following hypotheses. Null p equals 0.6 and alternative p is less than 0.6. They collect new data, and this time n equals 80 and x equals 38 indicate good health. So we're looking for the hypothesis test. So those ones are looking a hypothesis test you have to use p for. So do we just use 0.6?
Well, p hat is 38 divided by 80, isn't it?
Yeah, but we need to use p.
Oh, to see if.
Because the hypothesis test uses p, and confidence intervals use p hat. So how do we get p?
P is 0.6, isn't it?
Is it we just use what they tell us?
I think so.
Okay. So I think it'd be true.
Yeah, let's try.
16.67 and then 25.
Yeah. Let's.
Yep.
So p hat is the 0.47.
Yeah, it's easy. So it's 38 over 80.
Were you using Excel to do that? 15?
Yeah, I think so. Okay, so
Is the test statistic negative 2.282?
negative what?
2.282.
I got
What is that?
2.28.
You got
Where's the test statistic at?
the Z.
I got something totally different. What the heck did I do wrong?
So on the inputs, I have 38, 80. Is my sound on my phone?
No, it's fine.
Oh, to me it's not. To me it's messed up.
Oh, that's weird.
Just a lot of feedback.
Confidence level. I can hear the feedback. So I put the null hypothesis at 0.6 and then less than.
Oh, I didn't change that.
Is that right?
Okay, cool. That's what I got. That's what I was missing. So the null hypothesis, we put in 0.6 because it said P equals 0.6, and that was the null hypothesis.
Mhm.
Okay.
Did you get that same thing for 15, McKenna?
Yeah.
Okay.
For the p-value, did you guys get 0.011?
Yeah. What is the decision for this test? Reject.
It's low. Yeah. Is it B?
C. 4.C. Do you guys agree?
I said B. Is that what you said?
Yeah, that's what I said too.
Okay.
You said D?
Yeah.
Okay, cool.
Well, 15. Did I not save it? Oh, I just didn't save it. I guess that's it.
Woohoo.
Nice.
Okay, it's always fun.
It's
Always adventure.
been real and it's been fun. Ciao.
Yeah.
Good luck on my homework because it's probably way harder.
So true though.
Oh, all right.
Did you figure out the other one, Tori?
What?
Did you figure out the other homework yet?
No. No, I haven't tried it a second time. I'm just waiting.
You got this. You have faith.
Practice.
All right. Take care.
Bye, guys.
Okay. Bye guys. Have a good day.
Bye.